The big aha is to realize that if every node simply had a pointer to whoever was behind it, we never need to scan forward from the front to find our predecessor. So in other words, if 50 had a pointer back to the node containing 9, and the node with 9 in it had a pointer back at 3, and this node had a pointer back at the sentinel, then if we wanted to find any of our previous's, we just follow that pointer. So we end up with this topology here, where each node has not just an item and a next pointer, but also a previous pointer. And in that way, this list structure is often called a doubly linked list. Each node has 2 links. And that's as opposed to what we had before, which was a singly linked or only forward-pointing list. And so singly linked list, by the way, is what slist stood for. Now you know. So this approach is wonderful. And that once we've added these 2 links, our add method is fast, our get method is fast, and our remove method from either of the ends is fast. So any operations involving the ends of the list will take constant time, though operations in the middle will be slower. And we'll talk about alternate approaches for dealing with those later. But as far as linked lists go, this is the way that linked lists are typically done. Now this approach, while it works, it has this one limitation, which you will only really feel and come to understand if you try and code this thing up. There's a special case, which is that the last pointer sometimes points at the sentinel, and it sometimes points at what we'll call a real node. And so while that might not seem such a big deal here, once you try and code it up, you'll see that for each of your methods, you'll start running into these annoying if statements where you have to check and see if it's actually the sentinel. So we want to avoid that. So what we can do is try and be a little more pure. We're going to look to the heavens for inspiration and try and think, how can I make this just more perfect? So the most natural way to perfect our approach is to add a second sentinel. We could say, instead of having a last pointer that points to the last item, we're going to have a sentinel on both ends. Because now that we have front and back pointers, next and prev pointers, we can have a sentinel that's always at the front and one that's always at the back. So that the empty list has a pointer, or has a sentinel here at the front and a sentinel here at the back. And then as we add items to our list, we end up just slotting them in between the 2 sentinels. So this approach is nicer. It'll be much easier to code up than the naive approach, and it'll be equally powerful. And this is one approach you can use for project 1. Now, while this approach is nice and easy to code up, I think there's one better approach. This is the approach that if you went up to the mountain where the monk is, like hanging out in the mountaintop temple, and you said, what is truly the best doubly linked list? And you had to, it was a long climb, and it was just excruciating to get up there, and you really are asking for answers. This is what you would get, okay? In this approach, instead of having a sentinel in either end, you're going to have one sentinel that is both the front and the back. Well, how can that be? You might ask the monk atop the hill, and he might say, well, whenever you have an empty list, the previous is the sentinel itself, and the next is the sentinel itself. And at that point, you're getting irritated as a monk, and you just want answers, and you have to reflect a little. That's part of the glory of some of the most beautiful ideas. They take a lot of deep thought to really get. But in this case, as you add items to the list, you'll find that there's a very natural place to add them. So after we add the numbers 3 and 9, for example, we would say the sentinel, its next is 3, because that's the first thing we added, and then its next is 9, and then its next is the sentinel again. So in effect, it's kind of like the fact, the world's round. If I keep going in one direction around the world, I come back to where I start, and that's this approach. And so for example, if I do sentinel, dot next, dot next, dot next, I'm back to where I started. So this arrow in purple is sentinel.next, which is just the sentinel. And so while this idea may seem more confusing and a little silly, I encourage you, when you do project 1, do this, right? Understand the wisdom of the monk atop the hill, and enlightenment will be yours. So that's it as far as our doubly linked lists go in terms of topological improvements. And so just to summarize what we did there, improvement 7 was adding a dot last pointer to the last item in a list, and dot previous says everything should look behind it. But the problem there is that for each of our methods, we'll end up with special cases owing to the fact that, to this situation here, where this special case we described before. So to avoid those special cases in each of our methods, we can either have 2 sentinels, or we can make our list circular, and this is the approach I recommend for project 1 because it's cool. So to summarize all the things we've done, in the previous lecture, we made an S list, improvements 1 through 6. In this lecture, we've made the D list, 7 and 8. And so there's many more things before we would be up to par with the built-in linked list that's in Java. For example, adding exceptions and various other features. And we'll discuss those over the coming weeks. But that's the core of what makes a doubly linked list good. So there's a little bit more we're going to say now about making our linked lists even better.